More teaching materials may be found on the web at astro.unl.edu.
And so what I was going to do is just start off with is talk a little bit about how we get the data and talk about the telescope that we use for it. And actually, for this part, it would probably be easier just to bring the lights down, because you're going to want to see the screen more than you want to see me. Okay, so for this research project, and for most research projects we do, we get data from the telescopes at Kitt Peak National Observatory, which is, Kitt Peak is a mountain about 45 miles west of Tucson, Arizona. And this is a picture of the summit, and each one of these domes has a telescope in it, except for this dome. That's actually a mountain off in the distance, I think. An amazing coincidence that it looks like a telescope dome. And the telescope we use for this research project belongs to what's called the WIYN Consortium. And WIYN Consortium has two telescopes. It has this 3.5 meter here and this 0.9 meter down here. And these two telescopes work in a complementary fashion. This telescope has a narrower field of view, so it's more of a zoom in, and this telescope has a wider field of view. For this research project, we're looking at the Andromeda galaxy, so we want the wide field of view telescope because Andromeda is a very big galaxy in the sky. It's over 2 degrees, so it's about 4 to 5 times the diameter of the moon, so we want the wide field. So this is a picture of what the telescope looks like. And I'm sure most of you know this, but a common misconception people have when they think of astronomers, they think of us a bunch of old white guys in lab coats sitting up in a dome looking through an eyepiece. And of course, because of Far Side cartoons, we're always playing pranks on each other and things like that. But none of that's true anymore. And in particular, we no longer sit up in the dome. We instead sit down in a control room that's below the dome. And nowadays, this control room can be anywhere. It doesn't have to be next to the telescope. You can control telescopes over the internet. Another thing is, of course, we don't actually look through the telescope. We instead use digital cameras to take pictures of the things we're looking at. And so we sit down here in the control room, and these computers are here to use to control the telescope and the camera. And we also have an auto guider, which is designed to have the telescope track the night sky. And we also have a sleep control because we have a CD player because when you get time on the Kitt Peak telescopes is very valuable. For this telescope, for every 4 astronomers that ask for time, only 1 gets it. And so when you get the time, it's very valuable. And we observe from dusk till dawn. So in the wintertime, we can be up as late as 7:30 in the morning. And so that can be a challenge to stay awake. So you have to bring lots of loud music so you just stay up. The most important piece of equipment in the back is in the back here, and that's the coffee maker, and the microwave oven, and then of course the refrigerator. Because since we're at the telescope all night observing, we have to bring our food up that we'll eat throughout the night. So we're pretty much there at the telescope the whole time. Now, if we go up to the level of the telescope itself, this is what it looks like. And the telescope is the white part here, and then the blue part is the mount that holds it. So the blue part is the part, of course, that turns to point the telescope at the object you want to look at. And it is a standard Cassegrain design. It has a primary and secondary mirror, so the light comes in. It goes down into what's called the mosaic camera. So it goes off the primary, off the secondary, through a hole in the primary, and comes in focus in the camera at the bottom. The mosaic camera is a 64 megapixel camera. It's 8,000 by 8,000 pixels. And it's a $2.5 million camera. There's only 2 of them in the world, one here and then one at a sister observatory in Chile. And this instrument was built in 1998. The 64 megapixels doesn't impress the way it used to, but back in 1998, if any of you can remember what digital cameras looked like back then, this thing was amazing. It had so many pixels back in those days, the hard drives weren't even big enough to hold more than 5 or 10 at a time. It was really quite a challenge. The dome has vents on the side, and these vents are used, and they open up at night to help flush out the warm air that builds up in the dome. We are in Arizona, so it does get hot during the day, and that warm air makes the images blurry, so we try to get that out. And this is the dome's shutter, and of course, the dome rotates, hopefully rotates with the telescope, so that the telescope is always looking out through the slit. Though in recent years we've had problems with this, and more often than we'd like, we're often looking at the side of the dome, which is good. So I'm going to take you through a little bit of what a night of observing on Kitt Peak is like. The way that the telescope works, again, is you, twice a year you can submit an observing proposal requesting time. If they like your proposal, they give it to you, and they give you specific nights. And it's like a timeshare condo. You go up there on your nights, and you do what you're observing. And like a timeshare condo, usually when you get there, it's pretty messy. The previous astronomers were slobs, and so you have to clean things up. And part of that cleaning up is getting the computer set up, taking off their data, or copying their data if you like it and want to use it yourself. It's unethical, but you can do it if you want. And then what we do, we spend the afternoon calibrating the telescope. And so what we do is we take the cover off and we point the telescope at a big white spot on the side of the dome. And the whole idea of this is that when you're looking at an object up in space, of course you don't necessarily know what it looks like. And so we use this white spot to calibrate our observations. The analogy I like to use is when I was a kid, I loved to go to my parents' television set and they had all the color and contrast knobs down in front. I still don't really have that anymore. But I just love turning all the knobs, so when they turn on the TV, the sky would be orange and people would have purple skin and there'd be blue grass and things like that. And people knew that when you turn on the TV, of course, you knew that something was wrong because unless you're a K-State fan, you don't have purple skin. And if you're a K-State fan, then you already have a lot of problems already. So what we do is we point the telescope at this white spot and take pictures of it because it's a nice white spot. And it's easy to use to calibrate our telescope so that we can be sure that what we're looking at night looks the right way. So after we've got the telescope calibrated, we go down to the cafeteria. This is a picture of the cafeteria, and Doug, you'll be pleased to know that this picture has not changed in 12 years. It looks exactly the same as it did when you were there. And like most cafeterias, the food is pretty awful. But that's where we go to eat. And they'll also, as I said before, they prepare a night lunch for you that you can take up to the telescope. And then we go up to the telescope, and about half an hour or so before sunset, we start opening up the vents to start flushing out the warm air out of the dome. And we open up the shutter as well. And then another thing we do is we cryogenically cool the camera. So the camera itself sits in this big silver cylinder here, which is called a dewar. So hopefully most of you know what that is. It's just a giant thermos bottle. And we use liquid nitrogen to keep the CCD at a temperature of a minus 100 degrees Celsius. And the reason why this is it makes the cameras more sensitive. For those of you who use cameras, CCD cameras, you may have heard of something called dark current. And by cryogenically cooling our cameras, we get rid of the dark current. So it makes the cameras more sensitive. We can see fainter objects. A tradition in astronomy is to go out and watch the sunset. This was a particularly beautiful sunset this night because there was clouds out. Usually you don't want beautiful sunsets. You want the sunsets to be nice and boring because that means there's no clouds to interfere with your observations. And then once the sunset goes down, we start to observe. And this is a time-lapse movie that I made when I was at Kitt Peak actually a few weeks ago with my digital camera. And so of course the key thing I want to emphasize here is that you can see that the sky moves. This is the night sky sped up by about a factor of 30. And the telescope is designed to track the night sky. That's actually the moon, not the sun. And another thing this movie is nice at showing is the difference between what's called bright time and dark time. When the moon is up, it makes the sky brighter. Basically does the same thing to the sky that the sun does. It turns it blue. And so if you're looking at bright objects, you don't want this. You want what's called dark time, and the moon is down. But for the Andromeda Galaxy itself is so bright, we can look at it even with the full moon, and we do just fine. It's another just time-lapse movie showing essentially the same thing. And here you can see the dome moving as the telescope tracks across the night sky. And again, this is sped up considerably. You can see there's Perseus rising up over the dome there. And then after the moon sets, you can't see the dome anymore. So this picture right here is just a 10-minute picture from the back of the telescope. And of course the constellation of Orion right here. And the whole point of this picture is just to show that over the 10-minute exposure, the stars move from here over to here. And if the telescope itself didn't move, then the image would just be streaked. And so you can see the back of the telescope is blurred just because the telescope is tracking with it. So when you're observing on Kitt Peak, it's actually rather boring, assuming everything's working okay. Your job is just to sit there. You point the telescope at the object you're looking at, and you start the exposure. And then you sit there and you wait for the exposure to be done. In the case of the Andromeda Galaxy, we take 10-minute exposures. We take 3 10-minute exposures each time that we look at it. And while you're observing, all you do is just hang out and surf the internet and listen to music, and it's actually a lot of fun. One thing I like to do, though, is to just try to get outside and enjoy the night sky. It's just another time-lapse movie from Kitt Peak. I just had so much fun with this and decided to throw more in. This is actually with the fisheye lens. You can see Polaris right there. And so it's just nice to go out and enjoy watching the night sky. So here's the 4-meter telescope, and they're there as well.
Excuse me for interrupting. Is there a no-fly zone over the...
If there is, no one pays any attention to it. I don't think there is. It doesn't actually really affect the observations because it would be just very lucky, or actually very unlucky, if they were to fly over your field of view. It's more of a factor for the radio telescopes actually than the optical. So we observe all night, and then once we're done, we fill up the digital camera, and then like vampires, we try to get to sleep before the sun comes up, because once you see the sun, my brain just flips a switch, and it's like, oh, it's daytime, and it's hard to fall asleep. The dorm rooms, there are dorm rooms up there, and the dorm rooms have light-tight shutters so that you can sleep during the day.